everybody, it's Matt at MBE. Today I want to go over the proper fitment of your valve train parts and why we use the parts that we do. Okay, so we're just going to go through, first of all, we're going to go through the ID locator. Okay, we don't run cups anymore. The reason why we don't run cups, the cup would fit inside the spring here, and then you would have friction on here. So the spring is rubbing, creating heat. So we don't do that anymore. What we do is we use an ID locator. So meaning we use the ID of the spring to locate of the part to locate the spring. Okay, so as you can see, this goes on here like this and it fits. Okay, so when we got away from cups, everything improved by going to the ID locator. Okay, so but what we want to do is keep the center spring centered with the outer spring. So we got to make sure that the retainer fits properly also to the spring. Okay, so this has to be the same way. All right, so this fits on this lip and it fits on the inside here. And you don't want to, it doesn't have to be super tight, but it can't be loose. It can't be loose, everyone. Reason is we want to keep the center spring centered with the outer as much as possible. Reason is friction. So if you were to think of just my hand here, okay, and here's the inner spring and here's your outer. If we can just go like this, it's much less friction. If this is not centered and it goes in and it goes out and just tick, 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 I mean, this is more friction going in and out. Okay, this is no different than this. So we want to keep this centered, okay? And all this technology came from the cup stuff years ago when they were running 10,300 RPM and they were really doing development. And it's amazing. All this is available to everyone. Okay? All right. So we have this. Now we understand this. Now we're going to go to the valve and the fitment of the retainer to the locks. What we want, because there's a taper in it, there's an angle here. This is an 8 degree. Okay. This becomes a wedge on the stem, on the valve itself. So that will not move. That will barely even spin. We want this tight, okay? You don't want this spinning. You don't want it loose. Okay, reason is, you want to be able to pop that off, get that lock off. Because if the lock, if it's not wedged, the locks aren't wedged onto the valve, because in theory, you shouldn't even need the groove. In theory, the more the spring pushes on the retainer, the more it's going to wedge itself and the more it's not going to move, okay? If this is loose, like this one is here, this is an improper fitting lock, okay? So we'll go here. Okay, see, it will not wedge itself. These are both 8 degree locks. These two pieces just happen to be machined wrong. Okay, we check every single one that we assemble here. Every single set of locks with the retainer, we check to make sure they're wedged. Okay, what happens with this? This moves, it's moving up and down because this has movement, right? So what happens is you're relying on the lock groove itself to hold everything together. What ends up happening is this is moving, and then it snaps it off at the groove, okay? And then the valve breaks, okay? And the valve falls into the engine, and boom, we got a complete mess, okay? So that is the reason why we do that. The other thing is we don't run the black lash caps, okay? We run tooled steel. We buy these. This is a 310 here. For our 5/16 valves, we run 310 and 311s on the 5/16s, 311 thousandths, 310 thousandths. Okay, we want this to fit tight. So this is a 310 and a 310. I don't put 311s, so you can almost hear it as it goes on how tight it is. It actually has suction. Okay, the reason why we want this to be tight is so there's no movement back and forth, so it doesn't wear the tip of the valve out, and it's less energy on the tip of the valve, so everything fits properly and nothing breaks. Always remember, I would say 99.9% of valve failures are caused by the end user, not by the manufacturers. All right, so that today explains the proper fitment and buying the proper components for what you're doing. Thank you for joining us.